Hello everyone, welcome to our presentation. My name is Frank Tang and I'm joined with Ben Stewart and Eric Young. We are part of Team WWPD, or What Will Python Do? This presentation will show you what we've been able to achieve over the course of the CS Plus program over the summer on the What Will Python Do project. So a little bit of background on the WWPD application. WWPD is a web-based application that allows CS 101 students to strengthen their Python concept knowledge by giving them Python quizzes that they can then get the immediate feedback on. This project was originally a database project created by a different Duke student, and our task for this summer was to analyze and improve the WWPD application for a better user experience for future users. So without further ado, I will show you the original WWPD application that we were given in the beginning of the summer to work with. So this is the bare bones applications that we were given at the very beginning of the summer. This is the front page where you would create a quiz. Up here, you can see that we can choose the amount of questions that we want in a quiz. So in this case, we would get a quiz with 5 questions. And down here, we get checkboxes right here to indicate which topics that we want in the quiz. So for example, if I'm struggling with dictionaries and I want to practice my dictionary skills, I can select whichever boxes I want, including dictionaries, and I can generate the quiz by clicking get questions down here. And from here, it will generate a quiz that will have questions from those topics from the database. So in this case, I'm just going to click random answers and then click submit. And from here, it will give me a quiz results page. Now, we were unfortunately unlucky and we got all these questions incorrect, but the quiz results page will tell us our response, the correct response, and whether or not we were correct or not. And now you can either go back to create a new quiz, or you can generate the same quiz with the same settings in it. Students can also currently, with the old version, go to the student dashboard page, which will show them a table that shows their mastery level for a specific concept and function, just to show them how they're doing in the specific topic and function. And now I'll hand it over to Eric to talk about the advantages and disadvantages of the old WWPD application.
So as you all could see, the advantages of the original app is that you can make customizable quizzes in the concept page. The quiz gives you immediate feedback on whether or not you got a question correct or incorrect. There is very basic student response data, but you can analyze your past performance. And then we also have an instructor and course lab level page where instructors can look at some basic summary statistics on student performance in the quizzes. The disadvantages, however, the main disadvantage is that the UI or the user interface is pretty unattractive and basic, so we strive to improve upon that. Also, the data that is provided both on the student side and the instructor side is kind of too overly quantitative. We would like to add more visual representations and make it more intuitive for the users. And also, it lacks some instructor page features as well.
So then our goals for CS Plus are mainly to just fix those disadvantages. Primary goals were the user interface, just making it non-bare bones, making it more user-friendly, more responsive, and just looking a lot better. Then also to analyze the data from the past 2 semesters to see how people are using the app and then how we can design the app so it can adjust based on those analyses. Our secondary goals were instructor page visualizations. So not just analyzing the past data, but also setting up the instructor to analyze future data. We also, Eric took care of rewriting the question generation algorithms. So making them more user-friendly so we can read them and understand them better so we can generate new questions. Then also just overall testing and documentation. There were none of that, well, no testing, a little bit of documentation, but really revamping that and making sure it's perfect for us. So the timeline overview of what our project was. Phase 1 was just bug fixing and learning the code base. This took a little while because we weren't too familiar with the Flask app, and there were a couple bugs that were fixed, but it was a good learning experience. Then we spent about a week or 2 wireframing for a new UI, came up with a whole bunch of designs, and eventually just had to vote on one and go with it. Then we started doing analysis for the instructor page visualizations. This involved just a lot of looking at the data and creating different graphs to find out what would be useful to analyze. And then phase 4 was the implementation. This was the bulk of the project. It was just a lot of a lot of coding and dealing with CSS and getting the code base to work the way we wanted it to. And then finally, the phase 5, the one that we're wrapping up right now, is just finishing writing testing and documentation so future people can work on this project easily. The tools we used, source control was GitLab, Figma for wireframing, just basic HTML, CSS, and JS for designing the web app. It was a Python Flask application, so there was a lot of Python in the back end, and then we just used SQL for our database. So now I'm going to go ahead and demo our new version of the app. Cool. So here we are. This is the new concept page. You can see that now it's actually styled and looks a lot better. We have filters at the top. So if you just want to look at midterm 1, you can just click that, and then you can see how some topics fade out and other ones stay dark. And then you can just click them to select it. So let's just select like these 2 options. Again, you can set your number of questions, and then we could just go and generate a quiz based on these topics. So then once we generate a quiz, we can see that our questions are generated. Pretty simple design here. We can just kind of randomly select answers. And then you can see as all this is gray, but it's interactive. So we go ahead and click an answer and all turns blue to show that it's all been selected. You can see how many questions you've answered to make sure you have them all selected. And then once you've answered them all, you just go ahead and submit. And it takes us to the quiz results page. So randomly guessing didn't work too well for us there. But what we can see is we can see how well we did on different topics. We can see our overall. And then we can see that we clearly got this one correct. And then for question 2, we put this answer, but this one was actually correct. So just a very simple design, but makes it easy to use. And we still have these create new quiz buttons, but they look a lot better now and they're very clear. And just overall very functional and looking a lot better and clearer for the user. So now I'll pass it off to Frank so he can talk about the dashboard.
So if you remember back to the original demo of the WWPD application, the student dashboard page was a simple table with a mastery score in it, as well as the concept and function that that mastery score represents. We've totally revamped the student dashboard page to be more aesthetically pleasing, as well as moving away from a quantitative mastery score to a qualitative color code with these different key and mastery levels. At the very top right here, you can see this mastery at a glance. This is just these little squares indicate the mastery level of a specific topic and function that you can see when you mouse over it. And this helps to give a visual to the student of like where they have gaps in their understanding of Python knowledge. And these squares correspond down below, just they're organized by their concept instead. And it also gives them a little bit more information about the amount of questions that they answer about a specific function. So this is a much better student dashboard page and allows them to understand where they may need to work on their Python knowledge. Now that concludes the student side and all the front end implementation that we were able to create for the student end. I'll move over to the instructor side where we were unfortunately unable to style as much. We want to focus a little bit more on the instructor page visualizations, as we mentioned earlier, that including stuff like concept questions over time. Since one of the things that Dr. Stevens Martinez wanted was to be able to see how concept popularity changes over the course of a semester. So in this case right here, we pull information from the database in order to create this stacked area line chart to showcase how many questions were requested in a specific week of the semester. We can change the time frame by using these 2 date picker objects. So I can go back a little bit in time and show the amount of questions that were requested in a specific time frame. A good example of this, if we were to go to an extreme example, to go back into the 2019 semester, you can see that there's a lot of questions requested on the week of November 11th and the week of December 9th. And this is useful because this actually corroborates with the dates of the midterm 2 and the final exam. And our goal for using such a graph is to be able to see trends in popularity of concepts as the semester goes on and which concepts are the most popular or what students may be struggling with the most. We were only able to create 1, unfortunately, and something in the future we would just be creating more of these instructor page visualizations. But I would now hand it over to Eric to talk about the question generation algorithms.
Thank you. So I'll be talking about question generation, which was another aspect that we tried to work on. So first of all, we have working question generation code previously in the first version that we demoed. However, for example, just a general overview of what list append does. List append, this function generates SQL inserts for the question type list appending. But you can observe as you look at the code that there's a lot of randomization, if statements, and non-essential variables such as def that are floating around. If you look further down, this is also part of the same function. Some of the noticeable weaknesses is that there are no documentations across all of the functions that generate concept functions. There's a lot of repetitive code, and there's also lack of sub-functions that help contribute to a very confusing structure. So the consequences of this code base is that it is not very maintainable and reusable. And it's also hard to integrate for new team members who will work on adding new concepts and question types in the future if CS 101 expands or changes its curriculum, or even expanding the entire app to beyond CS 101 students. So the solution that we came up with is to design a new object-oriented question generation code base. The base class, which all of the subclasses or question types inherit from, is this class right over here on the left, which you see there are three main properties: concept, topic, and subtopic to become more specific. And there is 5 functions: get question body, get correct answer, get wrong options, check if repeat, and get SQL insert, which will be used by all of the subclasses or question types. So the abstract methods here are get question body, get correct answer, get wrong options, because all of the different question types or subclasses will have different implementations based on the concept. The concrete or final methods here are check if repeat and get SQL insert, which each subclass will inherit because the implementation will be the same. So a sample subclass is list add int. So as you can see, each subclass inherits from the base class, and the new property subtopic, which extends beyond the original concept and function, eliminates a lot of excessive randomization, if statements, and non-essential variables. So in general, this entire remodeling of question generation helps future team members working on expanding the code base to follow a format that can reuse a lot of code and follow a format that is more maintainable, so that if there are errors that arise in the original code base, it will be easier to clean up and debug. Also, the entire code base was added a lot of comments, as you can see, to explain what each incorrect answer comes from and what concept is used. So in conclusion, through CS Plus, What Will Python Do, our project, we were able to work in a virtual team environment through Microsoft Teams and Zoom, utilize a wide range of tools that we outlined earlier, learn web development, become better programmers through communication with our mentor and Professor Dr. KSM, and also finally make a tangible product and impact by creating this website, making this website better that will be used across all CS 101 students or even more students in the future. Thank you.